Okay, let's get continuity and one-sided limits. So let's pull up this picture right here. We have three graphs. The entire graph, all f of c is, or f of a, b, any point is continuous and uninterrupted, but we have one point here which does not exist, where the graph interrupts and there's a change. So here's one example, here's another example, here's a third example. So looking at this, let's take a look at one of our example questions. So this is our graph right here. This is f of x, x here. And let's look at our example. Find the limit of the greatest integer function f of x equal to x as x approaches 0 from the left and from the right. So we can see that x is approaching 0 from on this graph right here. This line's from 1 to 0. And as it's going to that, we have our next graph over here, which is -1. And so our answer here would be -1. It's approaching 0. As it's approaching 0, it's going to -1. Okay, now let's look at our next one. Look at our next question. A limit of x to 0 of x absolute value over x. I guess I can solve that one. Okay, so we can see that if you graph this question, you will be able to see that the limit approaches 0 from the left. So we have our graph right here. The limit approaches 0 on the left side. So we have a function and it's going here to 0. So this means our number has to be negative in the negatives and not positives. Not positive. And when taking the absolute value of a negative number, it becomes positive. So since we have an absolute value, we have a positive. Um, and so this means, and since we have our positive number, so we have positive, and then anything over positive, it becomes, and so we have positive over positive. But this means that it has to approach from the negative and -1. It's approaching from -1 to 0, and since it's negative, well, it turns to positive because of absolute value, and this just becomes our positive number, positive limit. Now let's look at our next one to erase all of this. Okay, now I'll give you a second to solve this one. Okay, so we have our graph right here, and this is more like a scene thing. So when the limit is approaching to 0 from the left, the value of x is negative. So as it's approaching 0, it's actually negative. It's this graph right here, and uh, and at x minus 8, you can see this is called unbounded behavior. We can see it from our previous lesson. We learned about unbounded behavior, and therefore it does not x is equal to -8 does not exist. But everywhere else it's continuous on this side and this side as well. There's only two graphs. So we have this right here and this right here. These two are continuous, and there's a line right here, which just x is equal to -8, which does not exist. Uh, so the limit does exist on both sides, right? Since it's in the middle. And as we approach 0, this number is 16, and this will be our limit right here. Thank you for watching. I hope this helped you.